Okay, we're going to talk about the risk engine settings that appear in the Appgate ZTP admin UI, specifically these settings, the fallback risk level score values. You'll notice that there are 3 of them. It's for each of the 3 main scenarios where an error may occur. You may have noticed also that by default, all of the fallback scores are set to high. So that means if any of these errors occur, the user and or device attempting to connect will be considered high risk. Now, perhaps you want to change that from a high, maybe a medium, maybe even to a low. It kind of does depend on your own environment and your assessment of the risk associated with these different scenarios. So to make that decision, it probably helps to get a refresh on how the risk engine works, how the ZTP controller uses the risk engine. So let's take a quick recap there. So general environment, there's a collective that shows here on the right side. And whether it's a connected collective or a hosted collective, it doesn't matter. The scenarios are really all the same here. So I'll just show a connected scenario. So I've got an ZTP collective on the right. I've previously connected it to my ZTP account. And within my risk engine service, I will have created a risk rule that goes to get data like security posture information from the third party. And that's what's shown here in the left. We've got a risk rule. It is constantly going out to third party to go get data about users and devices that it knows about. And it automatically calculates a risk score and it just caches those risk scores. It's just waiting for the next step. Right, and that next step is a user is looking to access a resource. So they log in using their Appgate ZTP client, and that pings the controller, and the controller then sends a request out to the risk engine service saying, give me the risk score for all the risk roles that you have for this user and or device. And that data comes back to the controller. It does all of its analysis and says, well, these are the policies and entitlements that the end user gets. And then the end user goes ahead and accesses the resources. Now we're going to take a look at this basic scenario and line that up with the different fallback scores. So let's take a look at it this way, right? We have 3 different fallback risk levels. Let's zoom in on the first one. So a rule or adapter is not working. So what does that really look like? Well, that typically is like there's some break. Something's broken between the risk rule, the adapter that's communicating with the third-party service. So what are some of the potential causes? Could be any number of things. It could be the credentials to that third party have changed. Perhaps the token or the secrets used to access it have expired. Or permissions have changed. Perhaps someone's changed how many permissions or what resources the adapter would have access to. Those kinds of events have to be taken care of within the third-party environment. Update the credentials or reset the permissions. It's also possible that the endpoint for the third party has changed. Perhaps a little less likely than the other 2, but still a possibility. Let's say the third party's moved from one domain to another, or you've changed your third-party hosting environment from one region to another, and that's changed the URL. So if the endpoint has changed, the adapter won't know and won't be able to communicate with the third-party service. A more drastic scenario is the third-party service is offline. It's just become unavailable. Perhaps more likely would be things like the route to the service. So that is the route from the risk engine service to the third-party service is somehow disrupted, disconnected. Or there may in fact be an internal adapter malfunction. So these are kind of the scenarios that would cause this kind of break. So this is if any of those conditions happen, if the risk rule was unable to communicate with a third party, then the fallback risk level highlighted here would be used instead. So take a look at the next scenario. What happens if the device risk data itself is not available. Well, that really means that the adapter has successfully communicated with a third party, and it's asked for all the data it has about users and devices so that we could calculate a risk score. But when the controller asks the risk engine service, give me a risk score for this user or device, it doesn't have any information because the third party didn't know about that user and device. And some of the potential causes include the fact that the device or the user were only recently added to the third party. Some third parties, they don't start reporting on security posture information immediately. Sometimes they'll take a day, perhaps a couple days before they can start to report. So if the risk engine service doesn't know, can't see any data because the third party doesn't have it, then the risk engine would say that there was no device data available. Or perhaps the device or user is just not known to the third party. And this certainly happens in scenarios where, let's say you've got an adapter that's going out to get security posture information from one endpoint protection tool, let's say CrowdStrike, and the user device that's trying to connect is really being protected using Sentinel-1. So a different risk rule would have been needed in order to discover that. And in some cases, we've seen a mismatch between the identifiers that SDP has for machines and users and the identifier used by the third party. For the most part, all that stuff gets worked out as we build out the adapter, but it's possible that the third party has changed the way that it identifies users and devices, in which case we'll just need to update the adapter. So if these cases happen, then the fallback score, the fallback risk level, will be returned here, again, shown as high. All right, third and final scenario is simply that ZTP itself is not reachable by the controller. That looks more like here. The controller, there's some break between the controller and the risk engine service. Now, could be just simply that the route to the service is disrupted. So the collective that you're running inside your own environment is unable to communicate with the ZTP environment. Maybe a firewall rule got put in place and that blocked the controllers from making the call. Maybe the route from the controller to ZTP somehow has a break. Or it's possible that the risk engine service itself would be temporarily offline. Nevertheless, if the controller is unable to communicate with ZTP, then it has this fallback score you can use. Now, just quickly coming back here, looking at these three, again, they're all set to high by default. And you can change them, but just note that keeping it at high means that the high risk likely means that your default to close. That is, you're going to block access to policies and entitlements if a user or device came back with a high risk score. So it's important to think carefully about changing this from, let's say, high, which would be a fail close, to something like a low, where you fail open. So imagine that you said the fallback risk level, if ZTP was not reachable, was low. Then if there were any break where the controller couldn't communicate with ZTP, then you're assuming here that all users and devices would be considered low risk, which probably isn't what you necessarily want, but it's just important that you consider what that default score would be and how you'd want to use it. For more details about the fallback risk levels, refer to the Appgate Zero Trust Platform User Guide.